Thanks everybody for joining us for our Go Aero expert lecture. We're so pleased to have Joe Darden from Iridium Communications here. And welcome to Gwen Leiter, CEO of Go Aero, to introduce him.
Hello, everyone. We are incredibly pleased that Joe Darden, who is the Director of Aviation and Business Development for Iridium, will be joining us today for this expert lecture. As you all know, Go Aero is supported by our ground sponsor, Boeing, as well as many other partners, including NASA and RTX, Honeywell, of course, Iridium, Global Aerospace, Reliable Robotics, and SAFT. So too, we partner with first response and aerospace organizations around the world to bring all of the programming that we have. We are very excited today to be able to welcome Joe Darden. As you now know, he is the Director of Aviation and Business Development for Iridium Communications, which is the only company that offers truly global satellite communications. In Joe's role, he is responsible for new business development in the Iridium Aviation line of business. Joe has had a very storied career. He leads Iridium's autonomous, remotely piloted vehicle development strategy. He also serves on the executive board of AUVSI's Washington, D.C. Metro chapter. He is part of RTCA, ASTM, and ANSI's committees on drones, so is incredibly knowledgeable about communications, about aviation, and frankly, about all that you are working on with your Go Aero flyers. So we are thrilled to be able to host Joe for this expert lecture. As you all know, Joe will be speaking, and you should feel free to use the functions to type in your question and answers, which we will ask later. So thank you very much.
Welcome, everybody. I really appreciate your time today. I'm going to go ahead and share my presentation with everyone here. So just give me a second while I pull up my slides. So thank you, Gwen, for the wonderful introduction. I really appreciate it. Iridium is extremely pleased to help support this mission with Go Aero. This competition is really the true spirit of aviation and innovation that we see as mission critical. So today I'll talk a little bit about Iridium. Again, my name is Joe Darden. I do believe that the Earth is round. It sounds kind of funny to say, but if you think about the traditional communication systems, whether they're geostationary satellites or terrestrial tower-based systems like cellular, they're designed as if the world was completely flat. If the Earth was flat, then geostationary satellites would be perfect and wouldn't fade or disappear as you increase or decrease your latitude. Geostationary satellites are 26,000 miles out in space, and radio waves travel at the speed of light. So that's about 40 times the latency increase. So also, because it's so far, a terminal using a geostationary satellite is going to have a larger antenna. It's going to have more power. So the size, weight, and power goes up exponentially because of the distance traveled. So if we zoom back down to Earth, we have the same challenges when you talk about terrestrial communications. Terrestrial towers have similar issues with horizon fading, or beamforms are line of sight, and once the horizon bends, a user on the ground loses the line of sight and the signal fades, and that's why you hand off to another tower as you travel around the landmass. So again, this technology would be perfect and better suited for a flat Earth, but that's just not how the Earth works. And since the Earth isn't flat, most people are surprised when they find out that terrestrial networks only cover 15% of the surface of the planet, or about 37% of the landmass. So traditional satellites, their coverage begins to fade at about the 60th parallels and then completely disappears after the 65th degrees. One of the points I'd like to emphasize here is that really there's no single solution that is perfect everywhere. Operators must consider their operations and systems that provide redundancy depending on their risk profile and their safety case. And so Iridium can kind of fill in all the gaps because we have a truly global coverage. And at Iridium, we think differently. We believe the Earth identifies as a spherical object that rotates on its axis, and our network architecture reflects these facts. Iridium is a constellation of 66 cross-link satellites, or space vehicles, or drones, as I like to call them, space drones. And our architecture creates this actual mesh network around the entire globe. And as you can see, from any point on the planet, a user terminal can see multiple satellites at any given time, allowing for passive, omnidirectional antennas, which also reduces the size, weight, and power. We also have 14 on-orbit spares in the event one of our satellite vehicles has any sort of a failure. And we have maximum overlap at the poles with minimum overlap at the equator in the beam forms. Those are the circles that you see here. They cast a shadow of about 2,800 miles per SV, and those overlap. The 66 satellites fly at about an altitude of 4,121 nautical miles above the surface of the planet, which if you look at that in terms of the latency, that's about 3 milliseconds as the speed of light and radio waves travels. So in 2019, Iridium upgraded our entire constellation, replacing every single satellite. It was one of the largest technology upgrades in history. The new satellite vehicles enable us to provide Certus, which is a more modern IP-based connectivity solution. And Iridium's advantage in the low Earth orbit neighborhood is the fact that we can provide low latency and we have a very low size, weight, and power profile because we're so much closer to Earth and so much more efficient. So Iridium, by the numbers, just a really quick snapshot. We have about 2.5 million subscribers. We generate about $830 million in revenue. We have more than 500 partners, value-added partners. We'll talk about that in a minute. And then we also have about 900 employees globally. And we look at our business and we divide that into these, what we call lines of business. And so from aviation, we focus on everything that flies, whether it be commercial air transport, high altitude balloons, uncrewed platforms of all shapes and sizes, anything that flies really. And then another interesting segment of our business is our PNT services, that's precision navigation and timing. So we have what we call STL, or satellite timing and location product. It's very resilient and provides a secure and resilient timing and location signal that is resistant to jamming and spoofing. Some common uses for Iridium in the uncrewed aviation space specifically are for command and control, telemetry, obviously PNT, backup communications, and even backhauling critical information like detect and avoid data. So Iridium's network architecture allows us to limit the ground infrastructure globally. Because of our crosslinks, we can run the entire network through Tempe, Arizona, which is where our gateway resides. We do down some of our traffic just to make the network more efficient. We have a teleport in Fairbanks, Alaska, one in Norway, and then another in Punta Arenas, Chile. And these are for our commercial gateway, and that allows us some efficiencies of working closer to the poles, so we can get in the event that we can't down the traffic in Tempe for whatever reason, we can back up into several other locations around the globe. So the way it works is your user terminal on the ground here connects to the closest satellite. And then that satellite can hop that traffic across the network to the closest point to ground. So it minimizes any of the latency. It gets down to ground to the gateway, whether a call is routed to the public switch telephone network, or it goes out to the internet via a secure internet, an open internet, or a cloud-based service. So we have over 500 partners, as I mentioned before. These are value-added manufacturers and service providers. They're really the engine of Iridium. These companies build products with Iridium connectivity inside. So we're a wholesale network operator. So these VAMs and VARs, they license our chipset, and build connectivity into their products. And so we have some examples on the next slide of some of these products and really what the core technology is. So these are the core technology here. This is the chipsets that are used for our products. And so for this competition, what Iridium is providing all of the participants and all of the teams is we're providing unlimited use on our network for airtime. So you don't have to pay anything for the access to the network and the airtime. There might be a small cost for the hardware. It really depends on your concept of operation and what you choose to implement and what kind of connectivity you need for your mission. And so I wanted to talk a little bit about the different classes of service and the different types of communication. So if you're more of a build type of a company and you want to integrate the chipset directly into your aircraft, then you would get a developer kit with a modem. It might take a little bit longer to integrate because you've got to do a development with a PCB board, and you've got to do power, and you've got to do antenna, etc. But these are the different classes of service. So in the Iridium narrowband, this is a messaging-based protocol. The raw operation is about 2.4 kilobits per second. The messaging is capable of sending about 300 bytes per message. So it's a very low bit rate, really appropriate for telemetry or flight termination services or some sort of an emergency communications method. It's not really something you want to use for an actual command and control. The next level that we have is our IMT messaging protocol. It's a larger message size. Again, this is a messaging-based transport, allows you to send up to 100 kilobytes per message, and it has a little bit better throughput. This is something, again, probably not best for command and control, but it's something that can backhaul telemetry data. You can even do some images, etc., to go back and forth to your aircraft. And it's something that's very small and lightweight and low power. These two, the Iridium Certus IoT and the narrowband services, these modems or chipsets are about the size of 2 American quarters. So roughly about the same size if you stack them on top of each other, and then about the same weight. It's about 11.25 grams. So they operate in a very low power environment. So 49 milliamps on transmit is approximately what these do. And you have a lot of different use cases you could use with these from a size, weight, and power perspective. To get into a more of an IP, background IP type of connection, the mid-band Certus is up to 88 kilobits per second. And this is what a lot of our operators in the uncrewed aviation space are using for command and control. Once you get an IP session started, you really are dealing in about 300 to 400 milliseconds of latency. And this is something that's really ideal for that command and control type of an operation. And you can do different things like backhauling detect and avoid data. You can push and pull different flight plan parameters and really have full control of your aircraft. So on the right-hand side, these are some examples of some products that have been implemented by our partners that are appropriate and have been used on various aviation platforms, with the exception of this one that has the kind of telephone receiver. That's really more of a maritime application. But these are all different devices, different shapes and sizes, different categories of devices that can be used in different aviation applications. So, and at the broadband level, this is a much larger, higher power type of a terminal. So it's really something that's being used in commercial air transport for cockpit connectivity. And so if you have a really large vehicle or heavy lift aircraft, this is something that could be appropriate for that. But generally, most of the smaller aircraft won't be able to tolerate the size, weight, and power. And as you can see, as you move up this scale of capabilities, the size, weight, and power does increase as your throughput and your capabilities increases as well. So there's a direct correlation there. So we'll go ahead and move on to talk about our satellite. This is the newer satellite and the capabilities here. And the reason why I wanted to talk to you about our satellite vehicle is, one, it's a relatively small satellite vehicle. It's about the size of a Mini Cooper. This is the main mission antenna. We also have a payload for Aireon, which we can listen to ADS-B traffic from outer space, and we provide that to air navigation service providers for airspace awareness outside of the traditional terrestrial-based communications. Well, one of the reasons I like to talk about this when we talk about uncrewed aviation is for more than 25 years, Iridium has had a team of remote pilots in command. What their official job title is actually space flight controllers. And so they have been flying these 80 aircraft for over 25 years. And it's really similar to a drone operation. And when we first launched back in the late 90s, we had about 50 of these space flight controllers on staff that commanded and controlled, did a lot of manual interaction with the aircraft, et cetera. And today, we have just 2 humans per 12-hour shift that function that role, that can fly the entire constellation. We've introduced a combination of autonomy and automation, and these 2 individuals per 12-hour shift can fly the entire constellation, and they can even do it from their iPhone. So it speaks to our legacy and history in remotely piloted aircraft or spacecraft in our case. And so if we have to execute a maneuver, the space flight controllers have to identify an object in space and then execute a deconfliction maneuver so we can avoid that. And when we're moving at 16 plus thousand miles per hour, just a little washer or a bolt that floats off of the International Space Station into our orbital plane can turn one of these satellites into a ball of plasma. So very high stakes remotely piloting. And so I like to say that our remote pilots in command have logged over 360 billion flight miles and about 17 million flight hours flying beyond visual line of sight in remotely piloted aircraft. So we've got a lot of experience there, especially in scaling in multiple aircraft by one pilot. One of the key aspects, Iridium operates in the L-band frequency. Our L-band is it's a longer waveform, and it's very resilient. And this is one of the reasons why our signal in L-band for aviation has been a protected spectrum globally, because it's weather resilient and it's a very robust signal. So think about our connectivity. For aviation, we are in the cockpit, we are not in the cabin. So for a pilot to ground safety communication, that's kind of the way that Iridium serves aviation today. And so really when you start thinking about weather interference and rain fade, it's not just rain fade, moisture, humidity, cloud cover, and dew. These are all different weather phenomena that can affect different types of satellite communications in the K-band. L-band does not have that challenge. It's a much more robust signal. And so when you think about our architecture as well, the mobile satellite services, again, the Earth is not flat. It's also a little bit bumpy in places. When we remove these limitations, you can really get into some scenarios where a traditional satellite communications and a geostationary satellite, if you're in a valley or behind a mountain, it's going to be block that signal. But because Iridium satellites are constantly in motion and you can see multiple satellites from every look angle, you're going to actually still have a connection regardless of where you are on the planet. Again, back to our legacy, and I'm going to start talking here about some of the use cases that use Iridium today to kind of show you the breadth of how an Iridium service connectivity can be used. This is an example of the cockpit safety. One of the things that we also offer in the safety services perspective is priority and preemption. So a safety call in a cockpit will be prioritized over other connectivity on the network. And ICAO offers those protections for our aviation grade spectrum globally as well. Again, weather resilient. This is critical safety communications globally. And it's a similar thing for maritime distress safety signal as well. It's prioritized on the network. So we see this kind of connected world in aviation where there's multiple networks and multiple modes of communication, especially with multiple types of aircraft and vehicles in the airspace. And so cellular and different terrestrial networks play an important role in being able to offer connectivity where they're available. And then where they're not available, that's kind of where you look to something like Iridium that can provide you that connectivity where no other connectivity is available. So again, some more of these use cases. These are buoys that are out in the middle of the ocean. The one on the right is a tuna buoy. And so what it does is it has sensors that can actually understand where the tuna schools of tuna are. And then they take that information and they send it back to a server over the Iridium connection. And they're able to actually sell that information to the fishermen so that they can fish and get their catch their limits faster, spending less fuel, less environmental impact. And they also provide the information to the ministries of fisheries who actually set the catching limit. And so it's a symbiotic relationship. So they're only able to get that information off of those buoys using that satellite communications provided by Iridium. To use a drone example, this is an aircraft company called Kite Aero. They're based in Australia, and what they've been doing since 2015, they've been providing medicines and critical vaccines to these remote villages in Vanuatu. And so these small island nations don't have traditional infrastructure, and so they used to have a healthcare worker put a cooler bag on their back and hike it through the jungle for 2 days to get critical medicines out to the villages. And now they can do this in less than an hour with this aircraft with a temperature controlled chamber in there, and they can deliver those vaccines or critical medicines to these villages in less than an hour. And this is transformative. Again, they've been doing vaccines since before vaccines were cool in 2015, and they use Iridium for their command and control and to monitor their aircraft operations. Sometimes you just need to call home. This is an example from the Polar Research Pod. That's what this device is here. It's a Polar Research Pod, and just being able to connect no matter where you are on the planet. It's a very valuable service. So we do a number of different partnerships and sponsorships. And so this is just a great image of what looks like just a Jeep driving through the desert. But really, this is an event called the Rebel Rally. And it's a race through the deserts of Nevada and California that empowers women who are re-entering the workforce. They use Iridium trackers, push-to-talk handsets, mobile broadband terminals to enable tracking of every aspect of this race. And they would not be able to do all of these communications because of the areas that they're in. It doesn't have any traditional terrestrial communications. So we keep them all connected and allow this race to continue every year. So Iridium also partners with the Smithsonian Movement of Life. And so where you might just see these kind of elephants, these are actually Laotian elephants that are endangered species. And so if you notice the necklace that the elephant has around its neck, that's a tracker. So now scientists are able to understand more than ever the entire life cycle of these elephants and animals. They're able to know where they breed, where they feed, how they do all these things, where traditionally they just use cameras and you could only see a snapshot of the life cycle of these animals. So when you reintroduce these species and try to repopulate these species, it's important to have a full picture of all these. And they're gathering all this information using Iridium. Another unique use, this is another drone example. This is FlyLogix. They're based in the UK. And this is an interesting one because I love to see different types of uses for the technology that do things that humans could not do before this technology. So this is an aircraft that flies offshore oil and gas platforms, and they inspect for methane emissions. So a traditional aircraft like a helicopter or a fixed wing aircraft generates too much wash from the rotors, and it disperses the methane, so you can't get an accurate reading. And it's too dangerous to send a human up to the tops of these stacks to really do the inspection. So they're able to do this and actually continue to improve the environmental impact for these companies by taking a measurement that you couldn't do before with any traditional other technology or means. This is another aircraft based in France. It's a slingshot takeoff and landing aircraft, and they're doing cyclone weather monitoring. So think about weather measurements, and if you have an aircraft, it can only get so close to the surface of the ocean to take measurements, and then the buoys that are on the surface of the ocean can only go up so high. So this aircraft can fly in the middle and get this middle ground that we weren't able to get before. And so they have a line of sight radio that can get them about 30 to 50 kilometers offshore. But what happens is if you're measuring weather, inevitably weather shows up. And so if a weather system moves in between the ground control station and the aircraft, they have to deconflict that, and they might have to fly 100 to 200 kilometers out of the way to avoid that weather to get back home safely. And so they switch over to satellite communications when they get out of range of their line of sight radio to be able to complete that mission. This is another company based, they're flying this mission in Southern California, United States. And so this is about a 15-foot wingspan aircraft. It flies for about 17 to 24 hours, depending on the payload, and they are doing pipeline inspection. And so you can see they have two terminals on this aircraft, a primary and a secondary, and that's the satellite antenna. And they can fly beyond visual line of sight with unlimited range. Their payload capacity are about 17 to 24 hours. And so what they'll do is they'll do a precision takeoff using a line of sight radio. And then once the aircraft gets airborne and they're past that precision takeoff and landing phase, they'll do a wing wobble, you'll see here. And that's the remote pilot taking over the aircraft. So the line of sight pilot hands off to the remote pilot, and they're able to fly the entire mission, and then they can hand it back over to the line of sight pilot when they come in for a landing 17 to 24 hours later. And so this aircraft has a waiver and exemption by the FAA to fly up to 8,000 feet, and they've got about a 45,000 square mile range that they can fly in the Central Valley of California. So no matter where you go, when you remove these limitations and you start thinking about the different types of connectivity, again, not a very flat earth. There's lots of bumps and all kinds of different conditions to really be considered about. But this is just an example of going to new heights here. And you can see this is a Garmin InReach device. It has an SOS emergency button, and they can send text messages from anywhere on the planet. So that's what really drives Iridium, is being that backup and safety communications, and that SOS button is so critical to our mission. Another example of safety in action, medical safety helicopters are using Iridium for tracking the helicopters for dispatch services. And now with Certus, they're able to actually send live telemetry from the aircraft so that the doctors back at the hospital can start troubleshooting and providing care when they're en route. A lot of military applications, again, various aviation and others. And so not only for the US DoD, but for ministries of defense all over the globe rely on Iridium for critical tactical-based communications. And it's really, like we say, we're in the cockpit, we're not in the cabin. It's really about getting things done. Critical communications, when it's an important communication, Iridium keeps you connected. And it's really up to you to really, sky's the limit. I guess it's not really anymore, but to really think about how you might use Iridium connectivity to help enable your mission for Go Aero competition and beyond. And so I'll go ahead and kind of push pause there. I'll turn it back over to the Go Aero team and see if there's any questions. My contact information is here. So if you're interested in including Iridium, or you need that connectivity, that over the horizon global line of sight type of connectivity, I'm happy to help you. We're going to provide you all that airtime for free. And then if you want to reach out to me, I can help coordinate to figure out what is the right solution for your aircraft, what is the right integration, how to go about that, and how you would actually implement an Iridium-based solution for your aircraft. So thank you for your time.
Yeah, thanks so much, Joe. I really appreciate it. So interesting to learn about all of the different ways that Iridium Communications is being used. I love that you're able to track those elephants and make sure that they're safe and okay. So that's very interesting how the technology is being utilized. Can you share just a little bit more about how, perhaps in this particular stage, or as teams are developing to their full flyers for the final fly-off, how they might incorporate some of the Iridium technology into their flyers to be able to utilize them to benefit them in the competition and beyond, and exactly sort of a little bit more about the details about what you are offering to the teams as well at this particular stage.
Yeah, so that's a good question. So I think I'll take it back to a couple of examples. One is this example here with this aircraft. They're using it for command and control, so giving it that direct connectivity from the ground station to the aircraft, and it really gives you unlimited range. You could have a pilot that is commanding the aircraft from Manhattan, New York, and the aircraft can be flying on the other side of the planet. This global connectivity with low latency, it removes those limitations, right? And so, but it's not necessary to have that low latency live command and control type of a communication. If you just needed to send a command to an aircraft to say deploy parachute or gather information and send it back to an operations center, you can also do that. There's a lot of different payload configurations. For example, this aircraft here, they're using Iridium for command and control, but they're also taking measurements and then they're doing some edge-based computing to understand what the ranges of values that they're looking for. And they're not backhauling all of that data over the satellite link, but what they are doing is they're identifying parameters, and if they have an exceedance, then they're sending that information in real time so they can actually address the problem in real time. So these are just a couple of different examples. Um, you know, Gathering information. One of the things that the Swoop Aero folks do is they send the aircraft with its package to deliver, but they also need to send so the aircraft in essence sends a text message to the healthcare worker in the village that says, "Hey, I'm arriving," and it gives them an arrival time, and then it communicates to them, "I'm descending to the landing zone," etc. So the aircraft is actually able to communicate directly with the village to be able to prepare them for the delivery. So there's just so many different types of uses and use cases. It's really unlimited in terms of what you decide to utilize. So I like to go back to this. It's anything from a flight termination service where you're saying, "Hey, something has happened to our aircraft or our flight. I need to send a command to the aircraft and contact the aircraft to send it to another place," or to deploy a payload, a sensor, or to gather information. So a really good example from, say, a fire scenario is you can have a drone that would be flying over with a particular sensor package that can detect where the hot zone in the fire is, and then that aircraft could use an Iridium transceiver to send a text message to the pilot of that's flying the fire retardant or dropping water drops to know exactly the coordinates and send them an image of where to drop the fire retardant. So it's most effective. I mean, there's a lot of different scenarios like this that you can actually kind of get creative with and understand. Once you understand the capabilities of the technology and the limitless connectivity, it's sky's the limit. So does that answer your question?
Yes, that's great. Really, really helpful. I hope this really gives the teams an understanding of just sort of the vast ways that the Iridium communications technology can be utilized. And we certainly do encourage you to contact Joe to learn more about how you can utilize the services as you are building out your flyers. A question that we have from the audience is, in the event of a dramatic emergency, such as the 7.0 earthquake in the Bay Area, has Iridium considered allowing unsubscribed phones to use the network for humanitarian purposes?
That's a really good question. So One of the things that Iridium is doing, and sorry, I'm flipping through all these slides. I just wanted to get to the end so you had my contact information. So that's a really good, it's a really good question. And so Iridium has a proprietary waveform today. And what we have done is we are working with 3GPP, which is the global standard for cellular communications. So there's really no satellites that just have a standard type of communication. In order to connect to a satellite today from a cell phone or from another device, you have to have a special chipset. And so what Iridium has done is we worked with 3GPP. We've rewritten the standards. So release 19 will include the Iridium technology, and we'll have the ability to roll out. Now, this isn't happening tomorrow, right? This is something that requires technology over time. But what we're doing is we're making it available to carriers across the globe. So not available today, but it's something that we are working on for the future to be able to have that critical connectivity anywhere on the planet from any device. That's the goal. So again, we're still probably a couple of years from that happening. But today you can actually have a Garmin InReach device or another device that actually connects to your cell phone that can provide that connectivity. So thank you. Really good question.
Thanks, Joe. If there are other questions, please post them in the Q&A function. I just want to remind all of our teams that Iridium is offering Stage 2 teams to utilize Iridium services and Iridium compatible equipment, access to the Certus aviation services valued up to $50,000 at no cost to our teams. So please reach out to Joe if you're interested and would like to be able to utilize these incredible services as you're building out your prototypes and your flyers. Another question is, I have an Iridium phone as part of my emergency grab bag, but I don't have a subscription. It would be great if I could use it when SHTF without having to first have a subscription. Any thoughts?
Well, you don't necessarily have to have the subscription. There is a prepaid option. You can actually get a prepaid scratch card to be able to utilize the Iridium services. So it's not something you have to pay a monthly subscription. You just buy, a bucket of minutes and it expires after however many months, but you don't necessarily have to have that subscription to be able to use it. You could do it on a prepaid basis.
Okay, great. Great.
And if you're a team member that is going to consider using that as part of your concept of operations for the Go Aero competition, happy to help you get that connected. Really just need to understand the use case and how you're going to be using it. And definitely, absolutely, that can be something that will be part of this competition. So reach out to me via email or just give me a call on my cell phone and we can talk about that.
Perfect. What factors should we consider when choosing an Iridium product?
Really what the use case is and what you're trying to accomplish specifically. There's different types of technology for different use cases. And so I would encourage you to reach out to me and we can talk about the use case and what your concept of operations are. And I can help make recommendations to the best overall solution for your aircraft or for your operation.
Great, very helpful. Can you offer some thoughts when it comes to the adversity and maneuverability missions in terms of the type of Iridium products that might be most useful in those types of scenarios?
Yeah, that's a really good question. So, we have a lot of electronic warfare, and we've got a lot of conspicuity issues globally, and especially in certain regions. And so, one of my recommendations for that is Iridium's PNT product, or we call it STL, but this is satellite timing and location. And so, it's a resilient signal, and so this uses our paging channel, which is about 30 times more powerful than the traditional Iridium signal. It's about 1,000 times more powerful than GPS. And so what this does is when you're in a contested environment, and this means when I say contested environment, let's not speak between the lines here. When you're in a scenario where you're actively being jammed, the jammers typically do not discriminate versus GPS or any other communication method. So our PNT signal is able to penetrate that. It's a much more powerful signal. And so the only way that you're going to have that signal not perform properly is if you're within 100 meters of the jammer. And even then it's intermittent, it'll still work intermittently. And so all you have to do is be able to see one beam from one satellite for about 4 seconds, and you can get an acquired signal for about you can get down to about 25 nanoseconds of accuracy on the timing. So that's an assured solution that can be used in any kind of an environment where you have contested communications or you have any jamming activity happening. So hopefully that answers the question. Great question.
Sorry about that. We had someone who joined a little bit late to the presentation, so apologies if this was covered, but are any of your modems, do they transmit a live camera feed?
They can, yes, absolutely. Really good question. So it really depends on I mean, we could transmit over really any of our live IP-based connections. So we have a partner company that has partnered with us called VideoSoft, and they do a software compression over any kind of a network. They can actually compress video over 2.4 kilobits per second. It's just a matter of live streaming that video at a relatively low resolution. You're storing the video on the edge, and then when you need to see more detail, you can kind of pull that across the network if you need a more high definition. So a good example is if you have a camera system that's monitoring a four-way stop sign, and it's just at a relatively low resolution, but you're getting that live feed, and let's just say a car runs the stop sign. You won't be able to see the license plate of that car because it's relatively low resolution, but all you have to do is highlight the license plate, and the system will pull those pixels across the network, and then you'll see that in clear, crystal clear quality. So that's kind of an example of something you can do over a relatively narrow bandwidth connection. And then you can also do something over more of our broadband connection that gets up to 700 kilobits per second. So that's a little bit better, higher quality, but you can even do it over the 22 kilobits per second link using a compression technology like VideoSoft.
Does Iridium have issues with connectivity in urban canyons, and to what degree compared to a GPS?
That's a really good question. So yeah, within the urban canyon, you might have some experience of increased latency. So you're not going to really get necessarily a drop or a loss of connectivity altogether. But because when you're dealing, like say in a city environment where there's lots of high tall buildings, you can get an obstructed signal, and some flight dynamics can kind of cause that. So you're still going to be able to get a signal, but you might have a slightly increase in your latency just because of the handovers, et cetera. So, but yeah, that can be a little bit of a challenge. But I would say from a concept of operations perspective, where Iridium would be used in that scenario, you would want to have a primary communication services based on terrestrial communication for the urban canyon, because generally the urban canyon is going to have a much more dense connectivity from a terrestrial perspective, and it's going to be cheaper and just as reliable. And so in that scenario, you would want to use Iridium connectivity as a backup to your primary comms.
Really, really helpful, Joe. Thank you so much. If there are any other questions, please let us know. But Joe, thank you so much for this incredible presentation. We are incredibly appreciative of Iridium's partnership and for offering these technologies and products to our teams. We very much appreciate it. And we encourage our teams to certainly contact Joe should you have questions or should you utilize the technology for your own flyers. Thank you so much, Joe. We appreciate it very much.
Absolutely. Thank you so much. We're so happy to support this incredible competition, and thank you so much for your generous time. Again, contact information is on the screen. Please reach out if you have any questions or scenarios, or you'd like to engage us to take advantage of our sponsorship. Talk to you all soon.
Take care. Bye-bye.